So a greenhouse is obviously, by its nature, trying to take advantage of sunlight. Therefore, they have to align their photo periods with natural daylight. They don't really have the option of running balanced flower rooms if they're trying to maximize the use of natural sunlight. So what do we see here? We see the sun is coming up and all that supplemental lighting is coming on to bring the facility up to, in this case, its target PPFD. This facility was operating on threshold controls, so they were looking to get up to their target PPFD. As the day progresses and more natural sunlight becomes available, we can see this drop in the load, and this is directly correlated to an increase in natural sunlight. I say it's directly correlated, not because it just is apparently obvious here, but we have additional data on solar intensity that we regressed against this and found correlations R squared of well above 0.9. We do see again that load shapes start to pick up in the afternoon as the PPFD from the natural daylight lowers. We need more supplemental lighting in order to achieve what we're trying to. And then finally, as the photo period of the flowering areas ends, we see the big sharp drop off. And again, you'll notice there's a gap here between this load and this load. That's largely attributed to the veg photo period and the veg lights. Greenhouse, or at least these greenhouses specifically, this load shape is driven almost 100% by horticultural lighting. There's very little in the way of electrically powered HVAC equipment in these facilities. The next slide, what about if we compare a greenhouse to a hybrid facility? Now I overlaid these two on top of each other, but let's not jump to the conclusion that these facilities are equivalent in terms of their size. I don't want you to look at this graph and go, oh, wow, a hybrid has a bigger base load. That's not necessarily the case. What I'm trying to demonstrate here.
Can you define what hybrid means for everyone?
Yes. Yep. So I'm using the term hybrid here. What I mean is a fully climate controlled cultivation facility, but with a translucent roof. So they're taking advantage of daylight. They still have supplemental lighting and basically a full-blown mechanical cooling and dehumidification system. So again, I put this on not to compare magnitudes of these facilities, but shapes, load shapes. And again, we see that initial pickup of load as the lights come on. This facility, though, had a much flatter load shape throughout the course of the day. I can say that this facility did not have lighting controls. They did not have PPFD or DLI-based lighting controls. It was done manually, and that is likely what we can attribute this flatness to. But it's difficult when they're operating the lights manually. It becomes much more difficult to sort of disaggregate that out of the data and understand the interactivities between HVAC and lighting in this particular case. So again, looking at these, understanding how very peaky they can be, understanding that what drives the loads in these facilities is the lights in the HVAC. What drives the HVAC? The lights and the transpiration of the plants. So anytime we want to think about demand reduction for these facilities, we got to understand those systems and how they are sort of critical to the mission.